So good morning, dear students. My name is Mitul Patel, software evangelist, senior application engineer in SOPAN Institute of Engineering and Design. We always works with one main vision, that is deliver more than promise. So before starting this webinar on manufacturing process and SATC CAM software, I would like to give you a brief introductions of SOPAN Group. Who we are. SOPAN Group normally runs in three firms. Number one, SOPAN Institute of Engineering and Design. It was first established in 2010 and it is the only one authorized training center of SolidWorks and Autodesk in all over South Gujarat zone. Number two, SOPAN Infotech, where various engineering services runs under SOPAN Infotech. Also, various live projects of SR and L&Ts runs under SOPAN Infotech. And we are also the reseller for ESPRIT CAM software. SOPAN Consultancy, where various consultancy works, recruitment and vacancies runs under SOPAN Consultancy. Now let's start our session on manufacturing process and ESPRIT CAM software. Before starting this, we should first know what is CAD, CAM and CAE. CAD यानी क्या? CAD is nothing but computer aided design, where all designs and drafting can be done through various softwares like SolidWorks, AutoCAD, CATIA, SolidEdge, NX, TopSolid, etc. Whereas computer aided engineering, where analysis and optimization of various design products can be done through various softwares like SolidWorks, NCs, etc. Now, what is CAM? CAM is nothing but computer aided manufacturing. So ये सेशन में हम कंप्यूटर एडेड मैन्युफैक्चरिंग क्या है वो हम ये सेशन में सीखेंगे with the help of practical live demonstrations through various ESPRIT CAM softwares. हम practical demonstrations भी देखेंगे. But before understanding this, what is CAM, we should first know basics knowledge of manufacturing process. What is manufacturing? So बहुत सारी definitions आपको पता होगी कि and you all had learned in various books also, and this simple basic definition तो सबको पता होगी, that is raw materials get converted into finished product. This is the simple basics definition of manufacture which has been given in each and every books. But इसके अलावा भी बहुत सारी definitions हैं जो हमें पता होना चाहिए. जैसे the manufacturing process begins with the product design and material specifications from which the product is made according to the need of customers. As per the needs of customers, also manufacturing process definition has been given. And one good definition is given by James Dyson also, that is manufacturing is more than just putting together. It's coming up with ideas, testing principles, and perfecting the engineering as well as the final assembly. Now, how many manufacturing processes are there? कितने manufacturing processes हैं? फिलहाल सबको पता है basic manufacturing processes are metal forming, metal casting, metal cutting and metal joining. These are the basic manufacturing processes which has been given in various books. But as per industrial point of view, how many manufacturing processes are there? That we should know. Number one, zero process. Casting and forming comes under zero processes. लेकिन ये zero process है क्या? Zero process is nothing but where various shape and size of finished product can be easily controlled by the dies which has been used in casting and forming without removal of materials, or we can say without wastage of materials. So that's why this process comes under zero process. Second, subtractive process. We can also say it as machining, where excessive amount of materials which has been removed with the help of various machining operations. So that's why this process comes under subtractive process. Third, positive process. Manufacturing structures can be made with the help of various weldings, fasteners. So materials has been added and that can be joined with the help of building and fasteners. So this manufacturing process comes under positive process. Now additive process. So additive process is nothing but a recent eras of manufacturing. That is nothing we can say it as 3D printing, और हम उसे रैपिड मैन्युफैक्चरिंग भी कह सकते हैं एंड मेटल डिपोजिशंस भी कह सकते हैं with the help of extruders. Various metals are getting melted and with the help of that extruders, that metal can be added to make a finished product with the help of 3D printing. Now, what is machining? Machining, with the name itself, removal of material from a workpiece. Yes, but they are categorized into two main categories, that is conventional and non-conventional. लेकिन हमें ये पता होना चाहिए कि conventional machining यानी क्या. This conventional machining is nothing but we can say it as one kind of traditional machining, जैसे lathe machine, milling machines with the help of various single point cutting tool and multi point cutting tools. Excessive material has been removed with the help of cutting tools. And one more thing we have to know under conventional machining, that is always cutting tools must be harder than workpiece, whereas in non-conventional machining में ऐसा जरूरी नहीं है. It may be softer material also. And लेकिन हमें ये पता होना चाहिए कि non-conventional machining use कहाँ पे होता है and when it has been used. जहाँ पे कोई complex structures has to be made, and as days are going, many new materials has been invented. Various hard materials which is not possible to get machined with the help of conventional machining, that can be machined with the help of various plasma arc machining, electron beam machining, laser beam machining, with the help of chemical machining. Various non-traditional machining has been used for the machining process. Now we'll skip on to turning. These all are the basics that we should know. What is turning? This turning is nothing but a machining operation that produce a cylindrical parts. So ये the figure itself हम clearly understand कर सकते हैं कि turning कैसे होगा. जैसे कोई वर्कपीस रोटेट हो रहा हो at some RPM, the cutting edge feed directions when it is parallel to the axis of rotation, that operation is nothing but we can say it as turning. Similarly, जैसे facing कब कहेंगे, जैसे जब cutting tools will move perpendicular to the axis of rotation of that workpiece, that operation is nothing but facing. So now you might be able to learn what is turning and what is facing. So with the help of this various operations, with the help of this video also, आपको clearly पता चल जाएगा कि how industrial operations has been done. So यहाँ पे, so you can clearly see with the help of carbide tools, various turning operations has been done. Rough turning, smooth turning. When depth of metal has to be cut more, that operation is nothing. We can say it as rough turning. The final finishing करना हो, that operation we can say it as smooth turning with the help of various carbide tools. This is nothing but a taper turning which can be done through various compound rest, setup of various tail strokes. So this all comes under turning operations. So you can clearly see from this profile turning, or we can say contour turning has to be done. It's only possible in CNC machines. This is nothing but forming operations with the help of the shape of that tool. With the help of the shape of that tool, that provisions has been made on that workpiece. So chamfering operations. So you can clearly see various grooving operations which has been done with the help of various CNC machine, and which kind of tools has been used, that things we should clearly visualize, because these all are the recent findings industrial operations that you should know. Now, what is milling? Milling is nothing but it is a process of cutting away materials by feeding a workpiece past a rotating multiple tooth cutter. जैसे हमने देखा in various turning operations where workpiece rotates and tool remains steady. Over here also यहाँ पे क्या होगा? Tool rotate करेगा and with respect to that workpiece will move relative to each others. So ये हमें पता होना चाहिए. And that things will comes under this milling operation. So it may be works under horizontal milling machines, vertical milling machines. So with the help of various operations, this millings may prefer. And with the help of this video also आपको clearly पता चलेगा कि milling कैसे work करेगा. So various end milling has been used, various shoulders has been used, various groove cutters has been used, various key slots and various operations which are really going under various industries. So you can clearly check it out from this video. So various shoulders has been used. So grooves can be manufactured through milling machines, but vertical flat machines, horizontal flat machines where grooves has to be made, that can be done through various milling operations. In simple language, with the help of various milling cutters. So this is nothing but horizontal milling machines has been used where cutters are mounted on that arbors. So we can say it as horizontal milling cutter also. So this is nothing but end milling cutters which are used for the periphery of the cuttings. So as per the requirement of operation, so these all cutters has been used. So various slots has been manufactured. So with the help of end milling, we can easily create that slots. So simple language, just as per its requirements, various tools has been preferred. So these all are the milling operations where thin sections of slots can also be manufactured or broader sections of slots can also be manufactured. So these all are the various milling operations which are really working in various industries. Now, what do you need for machining? Basically, for machining के लिए हमें क्या required है? Drawing the part, making 3D models, select appropriate machine tools, cutting tools, cutting tool, cutting data parameters, raw materials, and sequence. So we'll just check it out step by step. What basically we required for machining. First of all, for machining के लिए हमें क्या चाहिए? सबसे पहले तो drafting sheet चाहिए. It may be in terms of 2-dimensional also, or it may be in terms of 3-dimensional also. Just for an example, जैसे simple कोई construction हो और simple manufacturing product हमें बनाना हो, at that time with the help of 2-dimensional we can easily manufacture. But जहाँ पे कोई complex structure बनाना हो, and for that we required 3D models. For that, both the combination of 3D models and drafting sheet has to be there. So you can clearly see from this one drafting sheet has been done, and over here the combination of 2D and 3D sheets has been shown. So because every engineers read these drafting sheets only, because whenever we want to manufacture we require drafting sheets, because as an engineer we should know how to read these manufacturing sheets. Second, select appropriate machine tools. As per the drawing of that part and as per the operations of that part, how many operations we have to perform. On the basis of that, various machine tools has been selected. So you might be thinking, what is this machine tool? In a simple language, what is the difference between machine tool and tools? Many of the students don't know the difference between machine tool and tools, because all are thinking the tools which has been used in machines, that is nothing but machine tools. But you are completely wrong. Machine tool is nothing but the machine itself known as machine tools. Just for an example, lathe machine, milling machines, they are It comes under the category of machine tools. Lathe tools, milling tools, press tools. The name itself, that is nothing but machine. The machine itself is known as machine tools, cutting tools. Okay. So based on operations, based on machine tools, if that machine tools हमने select कर लिया based on part, okay, वो हम पता है. लेकिन कौन सा कटिंग टूल सिलेक्ट करना है वो भी हमें पता होना चाहिए. That is the main crucial things that we should know for machining. As per the operations, we have to select various cutting tools, but which kind of cutting tools material has to be selected वो भी हमें पता होना चाहिए. And for that we should know various properties of cutting tools materials. Number one, various cutting tools materials are there: carbon tool steel, high speed steel, carbide tools, cemented carbides, cubic boron nitride, diamond tools. These all are the various cutting tool materials. लेकिन कौन से ऑपरेशंस में कौन सा टूल यूज करना है वो हमें पता होना चाहिए. Number one, carbon tool steels. As we all know, carbon tool steels consist of 0.6 to 1.5% of carbon, which can work at 250 degrees Celsius. लेकिन more than 250 degrees Celsius पे जाएगा, it will start losing its hardness. So that's why these carbon tool steels are only used for soft materials like brass, aluminium, and magnesium. Number two, HSS. The name itself, it will work at high speed. So that's why the name has been given high speed steels. High speed steel consists of tungsten, chromium, molybdenum, which works at 650 degrees Celsius. It can easily maintain its hardness at 650 degrees Celsius. So that's why they are used in various machine tools cutters or various cutting tools like drills, reamers, counterbores, milling cutters are made up of HSS. Third, carbide tools. They are also known as vanadium carbide, or we can say it as tungsten carbide, where the addition of cobalt and nickel has been added as a binding agent, and they are manufactured with the help of powder metallurgy techniques. You know why they are manufactured with the help of this powder metallurgy techniques? With the name itself, tungsten. As you all know, tungsten has its highest melting point, so it is impossible to manufacture with the help of various casting processes and with the help of various machining process because it is the hardest material. So that's why this carbide tools has been manufactured with the help of powder metallurgy techniques, and it works 4 to 6 times faster than high speed steels, as well as it has high compressive strength, but they are brittle in nature and can't withstand the impact load. So as per requirements, this carbide tools has been used. Next, cemented carbides. Cemented carbides consist of aluminum oxide powder along with titanium and magnesium, which really withstand at 1000 degrees Celsius, and they are normally used where the stucking of that steel has been made, which can where where carbide tools, or we can say high speed tools, can't be used. At that time this cemented carbides has been used. Next, diamond tools and this cubic boron nitride tool has been used where various hardness has been required, toughness has been required, chemical and we can say thermal stability has been required. So this diamond and cubic boron nitride tool has its property where all these properties will runs on the basis of this toughness. So that's why they are normally used in iron and low alloy carbon steels. So these are the various cutting types, or we can say cutter types, which are used in various machinings such as end mills, ball mills, bull nose mills, lollipop cutters, turning inserts, gloving inserts, drills, threading cutters. तो हमने वेरियस टाइप्स ऑफ कटर्स भी देख लिया, वेरियस टाइप्स ऑफ कटिंग टूल मटेरियल्स भी देख लिया. Now we'll just keep on to companies who are manufacturing these cutting tools. हमें ये भी पता होना चाहिए कौन सी टूल्स, हमें ये भी पता होना चाहिए कि कौन सी कंपनीज कौन से कटिंग टूल मैन्युफैक्चरिंग करती है. So as per requirement, as per cutting tool materials, so this all companies are manufacturing various cutting tools, and as per its reliability, as per its durability, this cutting tools has been preferred. So various companies such as Hitachi Tools, Sandwich, Varicut, Nova, Vidya, Siemens, Zoller, Wintool, Mitsubishi, Horn. These are the various companies जो cutting tool बनाते हैं. And as per the requirements, this various companies has been selected. Now cutting parameters. Cutting parameters we can set as speed, depth of cut, fade. हमें पता है, सारे books में दिया. Speed always in terms of mm per minute. Feed in terms of per revolution or per stroke, depends on its operation, where depth of cut will be always in terms of Lekin, what is this step over and entry and exits parameters? So this step over is nothing but space between passes of a tool, यानी जो एक सिंगल पास में जितना कट करेगा, ठीक है, कितने स्पेस में वो मूव करेगा, that is nothing but that parameters we have to give on various CAM softwares. And what is entry and exit extension? So this we should know कि कहाँ से tool enter करेगा and after operations कहाँ से tool बाहर निकलेगा. That parameters we have to feed on various CAM softwares. So that's why these 5 are the cutting parameters that we should know during machining. And this step over and entry and exit parameters plays a vital role in various cutting parameters, and n number of parameters has to be considered for each one of these. Now raw materials, which kind of raw materials which has to be manufactured, यानी जो भी हमें फिनिश प्रोडक्ट बनाना हो, ठीक है, raw material कौन सा है, we have to know the properties of raw materials, because on the basis of that various cutting tools, various machine tools and various cutting parameters has to be selected. So we have to keenly observe and know which kind of raw materials has been used. And lastly, NC codes. If we are dealing with CNC machines, if we are dealing with conventional machine, it doesn't require any NC code. But when we are dealing with CNC machines, such as Siemens, Fanuc, Tucson, these all are the various CNC machines which only understands the language of NC codes, जिससे कंप्यूटर को सिर्फ 1 and 0 की लैंग्वेज पता चलती है. Similar fashion में this CNC machine understand the language of NC codes only. ठीक है. And one more thing I would like to tell you that जैसे लास्ट ईयर में नॉर्मल स्टूडेंट्स पढ़ते हैं रिगार्डिंग वेरियस कोड्स, एंड विद द हेल्प ऑफ दैट वेरियस कोड्स and as per the operations they start programming manually. लेकिन in our recent trending industries software इतना smart हो गया है कि it doesn't require any codes to be programming manually. That things can be done through software itself. Just हमें design बनाए and we just have to give various parameters. Automatically software itself will give us NC code, and we just have to feed that NC codes inside to that various CNC machines. So automatically that CNC machines will work on that NC codes. Is it easy? It may be yes and it may be no. Suppose we just have the knowledge of each and every parameters, okay, then every process will be easy. If we don't know, every process will be hard. लेकिन बहुत टाइम सारे इंजीनियर्स क्या मिस्टेक करते हैं कि ओके to every solutions, sorry, to every problem that is every solutions, सारे problems के solutions तो है, लेकिन बहुत बार क्या होता है कि we are unable to rectify problems, because if we are unable to rectify that problems, we are unable to solve that problems. सारे problems के solutions तो है, लेकिन क्या, हमें प्रॉब्लम रेक्टिफाई करना भी आना चाहिए, एंड रेक्टिफाई करने के बाद हमें सॉल्व करना भी आना चाहिए. So this aspirate plays a vital role in computer-aided manufacturing world, because this is the solution for many problems that has been arising through various computer-aided manufacturing. And dear students, I would like to just tell you one basic thing, that is, suppose students studying in 4th year, and when he will reach in 4th year,